Hello, this is a quick demo of interactive neural networks. So let's start with a single perceptron. You can first select different data points from this data point field. They are from two different types of dogs. One is Samoyed and the other type is Shiba Inu. And then after selecting a data point, it will be passed into the perceptron as input, and then the perceptron will generate a prediction. The prediction will be compared with the ground truth label to calculate the loss. The loss means that how our perceptron is doing in the classification task. If the loss is very high, then it means our perceptron is not so clever. But if the loss is close to zero, then it means our perceptron is good at classifying between two dogs. The next part is that you are given the full freedom to manipulate different parameters in this perceptron. In this case, there are two weights and one bias. You can click the upward and downward arrows to change the parameter and see how the loss and prediction are being changed correspondingly. And by the way, you can also click on this node and see how the value of it is being calculated. For example, this sum node, it adds together all the multiplication results of different pairs of input and weight. And then you can hover on different elements inside this formula and see what are the corresponding weights or the inputs that they refer to. So you can have a clearer idea how the results or value of a particular node is being calculated and what is the connection between different sections in this perceptron. The next part is here. In the data field, you can see the whole background is colored in either yellow or white. So it means how our perceptron is viewing this world. For example, with the parameter here, we can know that our perceptron thinks all the data points that lie in this white area should be Samoyed, and all the data points that lie in this yellow area should be Shiba Inu, which is not so correct because, as we know, the true data points are distributed this way. So as a result, we can see the loss is pretty high. It's even out of range. So what can we do about it? So as we are manually changing the parameters, we can see there is a certain relationship between this parameter and the final loss. This is because this weight is responsible for calculating the sum, and the sum is responsible for calculating the activation output, and so on, so on. It is finally responsible for calculating the loss. So we can see there is a chain of relationship between the weight and the final loss. So we can also think backward. If we want to reduce the loss, how are we going to change our prediction? Maybe to reduce the loss, we have to increase the prediction. And to increase the prediction, we have to increase the sum. And then we propagate back and back to the initial weight of our interest. This is the key idea of how are we going to use the loss to guide and how are we going to change every weight and bias. Since we know all the formulas between the subparts in our perceptron, for example, here we know the exact formula how the sum node is being calculated. Therefore, we also know the relationship between each subpart. And then we just kind of multiply the sub relationship together to get the complete relationship between the weight and the final loss. So we can use the loss information to guide our updates on weights and biases. you can press the step button here to automatically feed in the data and then update all the parameters for once. And then you can press it several times, and you can see the errors are growing smaller because we are taking smaller and smaller steps in our update. This is because in our loss function, at first the curve was really steep, and then the curve becomes more and more flat. If we click on this arrow, which means in the last step, we increase the weight by a certain amount, we can see a formula appears here, and when you hover on different elements of this formula, you will see this one means the sub relationship between loss and the activation result. This one means the sub relationship between the actual activation result and the sum, and so on. So this will show how are we multiplying the sub relationship together to get the full relationship and use it for updating our parameters. There's a note that the train button and the learning rate button isn't work pretty well, so please don't press them. Nothing will happen, but the thing will also not break. Then we come to the neural network, or you can say it's a multi-layered perceptrons. The things are pretty similar. So you also feed a data point into the neural network, and then it will try to generate some predictions. But the data field and the prediction nodes are missing here. I will include them in the future. But something is different with neural network. So, for example, for this weight here, it is responsible for calculating this node. However, this node is responsible for calculating all the 3 nodes in the following layer, and so on, so on. So in this case, the relationship between the weight and the final loss isn't a single path anymore, but instead it will be many subpaths. And then to get the full relationship between the weight and loss, we have to sum up all the relationship from the subpaths. This is the idea of back propagation. And then we can press the step button and then press it several times to see how the weights and biases are being updated. We can also click on the small arrow, which means the modification we do to a certain weight. And then we can see a formula appears. This formula demonstrates how we are adding together the relationships of subpaths together. You can see it's like permutation. We have a sub relationship for different subpaths, and then we add them together to gain a full picture of how the loss is related to this weight. And then using this, we can calculate the final change that we are going to make to this particular weight.